G'day and welcome back to my shed. This is going to be the last episode in a series about the DIY spot welder. I've developed this now to a point where it's doing what I want it to do, and it's functioning, doing the sorts of projects that I want to do. The only thing that I'm wanting to change is this set of electrodes, which I machined up very early on in the piece, mainly as a way of testing the welder and making sure it was working okay. The problem with this type of electrode is that it's very, very difficult to weld in close to a standing seam. In fact, it's impossible. Even with a slightly wider seam, you can get it, but you really can't get it as close as you'd like to that internal bend. So the sort of electrode I'm wanting to manufacture is a cranked electrode, and in the drawing here you can see that I've modelled up a electrode with the sort of bends in it that I want. I've cut some 8mm copper bar. This is actually over length. I'm not too worried about the overhang on the bottom of the electrode. It can simply protrude through the bottom of the electrode arm, but this bend at the top here I want to get as close as possible on both electrodes. It's important that these tips line up, of course, and although I've got a little bit of movement in the arms, I can shimmy those in and out and turn them radially as well. I want to get this as close as I can. So this is really an exercise in just basically seeing whether I can do it. I'm going to try using my milling machine, which has a DRO set up, and I'm going to try gripping the copper by this top section here, which shows on the drawings 15.09mm from the tip, and I'm going to use the vise and simply offset the vise by this dimension here, this 9.64mm, and then close the vise, and that should bend this section here parallel to the top section. This should be repeatable. I should be able to do it on the second piece of copper bar as well. Whether it works or not, don't know. We'll give it a go. So what I'm going to do is head over to the lathe. I'll prep these, get the 60-degree point on the tip, and machine the other end, deburr, and then we'll anneal the copper. I'd prefer not to anneal it. I'd really like the top of the electrode to stay hard, because the clamping pressure does tend to mushroom that very small tip very quickly. However, the copper will age harden, and it's going to work harden a little bit when we do the bending as well. So I'm not really sure how it's going to go just with the copper as it is at the moment. It's sort of fairly tough at the moment, so I'll try annealing it. Okay, so let's head to the lathe and see how this works. Okay, we're all set up to do the facing and chamfering at the bottom end of the electrode here. I just said I'd show you these tool holders that I made. These, I think they're called a POTS, P-O-T-T-S type tool holder, and I'd like to own a very expensive quick change tool holder, but at the time I built this I was on a very tight budget, and this was the best I could do. So the tool holders are held by a clamp with a split in the end of the tool holder, and it just simply slides onto this steel post. There's a screw that extends through the bottom of the tool holder with a lock nut, so once you set your tool height, hopefully they go back the same every time. You can rotate them any way you want. This tool that I made up here was a chamfering tool, and allows you to chamfer in any one of 4 positions without changing the tool. So you can rotate it like that to machine an edge here. You can rotate it that way to machine the inside of a bore. You can also machine the outside of an edge like we have there. It's really quick setup, it's easy to use. They're probably not as rigid as a good quality quick change tool post, but for the sort of work that I do, is mainly model engineering, I find these really good. So we're going to try and clean these up. I won't show you all of this because I'm sure you know how to do it. So let's give this a go. And just in case you're wondering, I'm taper turning with my top slide turned toward me, and I'm going to be putting the tool point on the back of the work, so that means I need to run the lathe in reverse to do this. Okay, so they're done. So I'm going to head over to the mill and, oh no, sorry, we're going to anneal these first. Okay, so I've got my copper sitting on some fire brick, just using a propane torch for this, and you've got to get these red hot. Everyone will tell you that you've got to immediately plunge these in cold water. You don't really need to. The copper will anneal even if you just let it cool to room temperature. This just speeds up the process. The other thing that when you're working with copper, you'll find that after you've annealed, you're going to get black scale all over the copper. The easiest way to remove that is to pickle it in acid. So I use sulfuric acid. You can use a mixture of salt and vinegar, which is relatively non-toxic. It's not going to burn your skin. and it works surprisingly well. But the sulfuric, I've got a big tub of it here. What I used to do was just plunge it straight into the acid, but in a workshop like this you're going to get acid fumes in the air that condenses out on anything that's cold, including all your machinery, and then you find that after a couple of days working with copper in that sort of environment that all your machine tools have gone rusty. So I prefer to just let this cool out in water, and then I'll put it in the acid, give it a scrub with some steel wool or a scourer, and then it's nice and pink and ready for the next process. So just pickling that, it's better if you can leave it for a while, but after a minute or so it will dissolve away the oxide on the surface and you're left with like a brown scum that you can clean off fairly easily. Of course the longer you heat it, the thicker that oxide coating gets and the harder it is to shift, but the acid does it really well. So that's more or less cleaned up, and we'll give that a scrub and get to the mill. Okay, so this is my milling machine. It started life as an old Denby horizontal mill and it came with a vertical head, but the vertical head that was on it was pretty hopeless. It was actually mounted on the horizontal arbor, and by the time you put a milling chuck on it and a milling vise, you had to extend the bed all the way down to the floor before you get any height above the vise. So the vertical head that's on at the moment is one that I built myself. It's manufactured from 3 aluminium castings, and it mounts on the overarm and bolts to that with a pinch bolt arrangement. The spindle itself is 4140 steel, runs on 2 tapered roller bearings. It's not the most rigid setup, but once again, when you're on a budget, it's the best I could do at the time. Love to replace it one day. I'd love to have a big Bridgeport or something like that, but don't have a lot of space in here either. I have fitted a DRO. I don't know if you can see that. There it is there. And that's going to allow me to get some accuracy with this bending process. There's also a variable frequency drive fitted to a 3-phase motor there. I don't have 3-phase in the workshop, so this gives me variable speed. The only downside is that I found it don't have a lot of torque in the low RPM, even though I've tuned the VFD as best I can. I'm considering putting a 3-to-1 reduction gearbox on the motor. I've already replaced this drive pulley and fitted a larger one, but even with that I can't get the low speed torque that I want. And I do have a CNC mill over there. I probably do all my high-speed machining in that. This one I want mainly for large milling cutters, facing cutters, slitting saws, that sort of thing. So I sort of need the bottom end power with this one. Anyway, let's have a go at this process and see what happens. Okay, so what I'm going to try to do now is to I've got the collet reasonably tight so that when I clamp it right up it's not going to draw up too much into the collet body, and I'm going to bring the tip of the electrode up on the vice jewel until I'm just touching the face of the collet, which it is there. Okay, so it's just touching. What we can do then is zero out the Z-axis. Get that up into the collet. And I'm just going to raise the vise now until I reach this dimension here, this 15.09. That's going to put the straight part of the electrode into the collet by that amount. That's the theory anyway. Okay, so let's bring that up. So it's 14, it's 15, and 0.9. Okay, so I'm going to lock the collet there. Alright, so now I'm going to zero that Z again, and the next step is to bring the vise up by whatever this dimension is here. Now, I made a bit of a blunder when I cut these blanks for these electrodes. I didn't machine them to exactly that length of 59.5 because that's the bent length. I knew that that being straight, it's going to measure out different to that. So I just cut them oversized. They're about 70 millimeters. So I've actually measured them, and I've subtracted off this total dimension here at 32.4, and I get 36.96 as my dimension. So if I bring the vise up now by that amount, 36.96, and then make the bend with the jaw resting on this point here, which will be the inside of the bend, hopefully that's going to do it. So I've zeroed my Z. I'm going to bring the vise across a bit, and I'm going to have to move the electrode into the center of the vise. Just so I get enough depth in the vise to do that. Alright, so now if we come up by that dimension, 36.96, we'll see how we go. Okay, that's it there. And what I want to do now is to bring the back jaw of the vise across till it's just touching the surface of the copper. Okay, that's it there. Now, if I zero out my Y, and if I now move the vise by this dimension here, 9.64, that should give me this top bend. So we'll see how that goes. So 9.64. That's it there. Oh, that's cool. We got a bend. So the next step is just simply to close the vise. So let's see what happens. And that copper is very, very soft, so I don't want to squash it. Yep. Cool, that worked. There it is. You can see how, I don't know if you can see it, that copper was so soft that pushing it up into the collet has actually left a little shoulder there. But, let's just see. That's not bad. I'm happy with that. Okay, so the whole deal now is that that should be repeatable. I should be able to do the same again with the straight one, using the same offsets and dimensions, and we should get two identical electrodes. So let's go. Alright. Okay, back on the air. You wouldn't believe it. I just went and measured this one. It was 0.02 of a millimetre different to the other one, even though I just totally random cut them and faced them to length. So that one's now set up inside the collet chuck by the correct amount. Lock that. Okay, so we're going to zero our Z, come up again, this time by 36.97. Okay, that's done. The device can come across. It's just touching there. So 0Y. Okay, now we come across 9.64. That's it there. Right, close the vise. That's it. There's the second one. Okay, I'm hoping you all wanted to see whether they actually worked in the welder, so there they are. How's that? So I fitted those up. They didn't line up as perfectly as I thought. There's about a 0.5 millimeter difference, but I can loosen one of these arms and just slide it back into its socket to get that alignment correct. The real test though is just to see how soft these still are. I'll have to do a few welds with it just to see. But all in all, I'm happy. Was it worth it? Probably not. I could probably just put it in the vise and bash it with a hammer and I would have got close. But there may be a time when you need to do something which has got to be very precise, and where you want to line up with an existing part, or whether you want to have two parts which are identical. It certainly needs a bit of tweaking. The method that I used, I'm sure I could streamline that and have it work better than I did. So I'm going to wind this Spot Welder series up now. This is the last video, and I'd like to thank those people that have commented on my other videos. Never thought I'd say this, but I'm happy if you give it a thumbs up, and if you like to leave a comment or ask a question, I'm happy to field those questions. So I've got a few more videos in the pipeline, and they're not going to be about spot welders. So until then, thanks for watching.